Hello everyone. Welcome to Code with Vishesh. With a 2 day gap, we were not able to cover this stack fully, but we will cover our stack journey by end of the this month. That is only today and tomorrow itself. So coming on today's problem. So today our problem is online stack span. In this problem, we have given a share market price value, and there are given stocks and their span. So our target is to return the consecutive maximum number of days on which our stock price was less than or equal to our current day element. What does it mean? Let me explain you further by an example. So let's take an example where we have 7, 2, 1, 3, 3, 1, 8. These are the values. Like 7 is the first day itself when our stock was opened in our market, and on the next day it was opened with the value of 1, and with the value of 2, and with the next day it opened with the value of 1, and further on 3, 3, 1, 8. These are the different values on different days where our market starts. So what we have to return? We have to return the maximum number of day streak, means the maximum number of days consecutively when our stock's price value, whatever will be the value that is given, it should be always less than or equal to our current day elements value. Suppose for the 7 itself, it is the day 1, so its value will be 1. In 1 is the only consecutive day, because 7 is greater than or equal to itself 7, so there will be counted 1 day. For 2, because for 2, if we check previous days, so there is only 7, and 7 is greater than, not less than or equal to 2. Thus, we will not count 7 in a consecutive day, and thus 2 will be separately a one single day on which the stock price was greater than and equal to itself. Next come upon 1. So for 1, 2 is also greater than, thus 1's count will be also a 1 only. But now comes 3. So for 3, we can have a different count. Like we will be traversing from our current element to our zeroth element, and we will be checking is the value that is given on our previous day is greater than or less than equal to the our current value. If it is means if our price, that in this case 1 is less than, and it is less than 3, thus there are two consecutive days, and now mm, again traversing back then 1, so there is 2, and 2 is also less than 3, thus we have 3 consecutive days when our stock price was less than or equal to our current day's price. So and after this, if we go, there's come 7, which is greater than, thus the maximum streak for these 3 days was 3 day. So that's how we will be continue our next element. Like next element is 3. For that, 3 is greater, it is equal to 3. That's why it is also counted, and 2 days are there counted. After then 2 and 1 are also smaller, thus 4 day counted as their maximum days. And after that 1 day means one value comes, and 1 is itself is smaller, it's not greater, that's why not counting, and giving only a 1 as a single day consecutively where we have our value less than or equal to itself. And in the end we have value 8, and 8 is greater than every above values and every previous value, thus the maximum streak goes to 7 days. So how we will do this question? For the brute force we have talked earlier, and now we can understand what I am using. We are taking a dynamic array and putting the elements in our array, and traversing from our current element to the previous up to 0, and simply checking condition is our simply adding the element in our array itself, and then checking the condition is our array of I is less than or equals to our value or not. If it is, then we will increasing our counter, and if it is not, just break out. And initially our count will be initialized as 1. Why 1? Because a single day itself count as 1. That's why we will be initialize count as 1. And after this we will be returning the count, and the maximum count, that is our maximum consecutive days that we have got. And that's how we will be able to solve this problem. For coming upon complexity part, its time complexity will be big of number of days, because the number of days we are traversing, so its time complexity reaches to big of number of days. While for the space complexity, uh, our space complexity will be total number of calls, means how much time we have call the element while traversing from current element to previous up to 0. We are counting or calling the element again and again. So total number of call will be the total space complexity that we will be taken in our dynamic array. That's why it's not the best solution. So what will be the better solution? So for the better solution, what we actually need to understand is, we are not trying to put element and checking them. Although our target is fixed, we have to get the element that is previous greater element of that current element. If we understand our previous journey, we have learned the smaller previous greater element, previous smaller element, next greater element, and next smaller element. So in that part we have understand them. So in this question, our main target is to get the previous greater element. Whichever will be the previous greater element, its index will be subtracted from our current in value or current elements index, and whatever will be the result, that is the maximum consecutive days that will be possible, and that is what we have to return. So for the optimal solution, our task is simple. We will be taking a stack, putting a pair that contains the element value and their index, and trying to get all elements previous greater element, and returning the maximum element or maximum consecutive days that we will be got in our journey or in our traversal. So coming upon the pseudocode, we will making a class of stock spanner, where we will have a stack of a pair, and in our stack I have discussed in our value and index, two different values will be inserted, and they will be in a int form and a pair form, and stock spanner will be called, and index will be initialized as -1 for if there is no any element that encounters, so our index will be -1. And we will be checking that our stack is already clear. So now coming upon our functional part, so we will having our next function that contains a value, and in this our index will be increment by 1. Index is equal to index plus 1, and now we will be traversing if our stack is empty or not. And if it is not empty, then we will be checking our stack stop element dot first value, means our value is less than or equal to our value, that is our current element value. If it is the case, so we will just pop it out, because we don't want that element, because our stack stop dot first element is less than or equal to value. What does it mean? It simply says that our value is greater than or equal, and we have to get the smaller value, not the greater. So we will just pop them out, and after popping them out we will store our answer, and we know what will our answer is. Our current element means our values index element index minus our stacks top dot second value is our answer. So index minus stack, we will be checking our stack is empty, so our index minus 1, that is our empty stack case condition. And if it is not, then we will be minusing index index minus stack dot second value, that is their index, and this is our answer, and we will be pushing that current value in our stack, and after this we will be returning our answer. So let's analyze it by giving an example. We will be taking the same example, 72133118. So firstly we will be putting the 7 with index 0 in our stack, and for this what will be our answer is, so our index is 0, so 0 is our current element, so 0 minus our index is initialized as -1, so 0 minus -1, that is 1, so 1 day streak is given. And now because it is greater, so and it is the first element, so we have not to worry anything. And now moving to the next element, so it is 2 with index 1, so 2 is less than or equal to 7. That's why we does not need anything, and simply put 2 comma 1 in our stack. And for this our current element that we are standing is at index 1, and our previous element is at index 0. So 1 minus 0, that is nothing but 1. So it is also a 1 day streak. And now comes 1. For 1, 2 is greater. That's why we are putting that element and calculating their answer. So 2 minus 1, index 2, at 2, our 1 element is present. And at 1, our previous greater element is present. So for 1, 2 is the previous greater element. That's why we are subtracting it. So in our contextual way, I can tell that our current value minus previous greater element index, that is our answer, and that whichever will be the maximum of them, we will be returning that. So for 3, our previous greater element, now calculating the previous greater element, 1 will not be the previous greater element for 3, 2 will not be the previous greater element for 3, so both will popped out, while 7 will be the previous greater element for 3. So 7th index is 0, and our current element, that is 3's index is 3. So 3 minus 0, that is 3. So 3 is the consecutive days that we calculated from this formula. So that's how we will able to solve this problem. Coming upon the complexity parts. So we have earlier discussed why our complexity is big O of 2n, because we are traversing and putting the element in this stack. So both are taking big O of n in time. That's why our time complexity will be reached to big O of 2n, while the space complexity is big O of n, because there will be the maximum case where we will be putting n elements in our stack. Suppose there is a case of 7 6 5 4 3 2 1. So in this we does not get any, and we will be getting a -1 value is our previous greater element. So in this case we have got complexity of big O of n. That's why its complexity is big O of n, space complexity, while the time complexity will be big O of 2n. So that's how we will able to solve this problem, and with this problem we are up to close to our stacks journey, but we will be continuing our journey and practicing some question, and after that we will be switching to next topic. So until that, stay tuned, stay happy.